Okay, hello. My name is Jim Sims from Hamamatsu, and today I'm going to talk to you about our new camera, the Quest. This is a camera that is photon number resolving. What does that mean? That means that we can count individual photons starting with the number 1. How do we do it? All right. This is a typical chip. This is a typical pixel, and there's all that noise on there. You saw this yesterday in your lab. You drew that little line profile, and you saw the noise randomly bounced around kind of an average. Maybe 10 pixel values above, 10 pixel values below. So you had a range of maybe 20 pixel values of noise. And then a lot of you discovered that a pixel value of 2 equals 1 photon. Well, what does that mean? That means that when you've got photons raining down on it, that the first few are lost in the noise. Now, you've detected them, but you have not resolved them. You don't know how many you've got. Now, look at this. This shows that here you need 1, 2, 3, 4, maybe 5 photons before you start to be able to resolve them, before the signal extends beyond the noise. So how do you improve the resolving ability of the individual photons? Well, you come up with a quieter chip. Now look, you start to resolve the photons much earlier because the noise is lower. What did we do with the Quest? Ta-da! That. You get 1 photon, and it's already so far above the noise, you can resolve it. So we've got a camera now that you can have a 30-second exposure on. You can photon resolve individual photons and count them. And we've got a mode for counting them. It ends at 200 because if you've got more than 200 photons, you don't need to be counting them. You know, it's like spare change. You know, if you've only got a nickel, it's important that you know it's 5 cents. If you've got $50, who cares what the change is? All right, let's talk about the single greatest person in the history of light, Albert Einstein, whose son is buried here in Woods Hole. He was able to prove with the theory of the photoelectric effect, for which he won the Nobel Prize, that light is in fact a particle of energy. It's selenium or it's silicon like we use, and it kicks off an electron. Great. Now, we already knew from Michelson and Abbey and stuff that the light travels in a wave. Einstein was okay with that. Okay, it's a particle that travels in a wave. It's okay, you know. And in the eclipse of 1908, he was able to demonstrate that light, which has no mass, is still affected by the sun's gravity, because when the sun was blocked by the moon, the stars that were nearest to it had shifted in position because the gravity altered them. He was like, oh yeah, it's good. But he also predicted black holes, gravity so intense that light can't escape. He had no way of proving that at the time. It was only on papers. It was math. And he came up with quantum entanglement, where 2 photons are generated, and although they go off on their merry ways, their fates are linked. If this one turns left, this one turns left. If this one turns right, this one turns right. He called that spooky action at a distance. And at that point, he's like, oh, mein Kopf. And he pushed aside his beer, and he went to bed. Einstein had a mind before the means by which to prove such things. Quantum entanglement does exist. Don't ask me to explain it. Now let's talk about Leeuwenhoek, the guy that invented the microscope. All right, this guy, he made drapery. He was a draper, all right? He made curtains. But he wanted to see the fibers up close. Oh, dear God. And so he invented the microscope, and he started to see these little animalcules. It took 150 years before anyone realized that these things were what we're made of. We're made of cells, and then that germs cause disease and germ theory. And, you know, 150 years, no one really knew what to do with this tool. All right. I told Jorg about the Quest. He's like, well, what are we going to do with it? I said, I don't know. Now look, up until the last couple of years, this has been the situation for everybody. You know, you've been begging for photons, but now that we've got the Quest, I got good news. Found it. All right? And those of you that are going to ask me, hey, Jim, what do you think if should I buy an EMCCD? I am going to say, yes, your grant money for the EMCCD is perfect. But here's what I really think. I never say it out loud. So I present to you the Hamamatsu Quest, and I encourage you to go on an adventure of discovery, because we have created a tool for which we have some good ideas, but not yet great ideas. But like the microscope, there's something out there. Thank you.